It's incredibly easy to fall into the trap of using AI for everything. Many teams are starting to integrate AI agents all across their systems, and why wouldn't they? AI agent systems are undeniably powerful. There's no doubt about it. But we need to stay strategic about where and whether we want to inject AI into our systems. AI is not magic, and it's not the best solution for everything. Just like any engineering decision, choosing to use AI or not, and at what scale, involves trade-offs across accuracy, cost, complexity, and risk. Most problems in software and data systems can be solved in one of these four ways. Humans, for humanity and judgment, rules or code-based solution for deterministic logic, machine learning for statistical pattern recognition, and generative AI systems for flexible reasoning and generation. These aren't some ladder that you progress through from human to agents. In fact, they are distinct options, each with a very specific role. The goal is to pick the right system for the right problem. Let's start with humans. I may have a little bias here, but humans are great at making complex judgments. People can handle ambiguity in edge cases very well, making complex decisions with incomplete or conflicting information. Particularly, they can also apply context, ethics, and accountability in ways that machines cannot. Humans should drive tasks when there are high-stakes decisions, situations requiring ownership or liability, and cases of significant ambiguity. Some examples of these are hiring decisions, medical diagnoses, legal interpretation, and large-scale strategy or financial decisions. If something goes wrong, accountability must be with a real person. Now for the trade-offs. Human judgment is high quality, but expensive, slow, and very hard to scale. If you think about hiring a candidate for a job, you could screen resumes automatically, but the final decision involves more nuance, such as team fit and communication skills, which are not something you want fully automated. On the other hand, you would never rely on humans to manually review every single transaction on a credit card network. That's millions per second. So let's look into some of those cases where a code or rules-based deterministic system might be beneficial. In particular, a traditional software solution is good at executing clear, stable logic and producing consistent, exact outputs at scale. Rule-based systems are ideal to use for tasks when logic is known and explicit, for example, if X, do Y, requirements are stable, and errors are unacceptable. Some examples of these are payment processing, input validation, data transformations, and most importantly, security and access control. Code is fast, cheap, reliable, and very interpretable. It's generally straightforward to test, debug, and scale. If I want to process a credit card payment, for example, I want a code system to check if balance is sufficient and approve or decline. This should be as fast as possible, deterministic, and have no room for error. Using AI in this case would introduce unnecessary risk. Same for validating an email address format. You don't need a model. You need a simple rule. But where rules fail and begin to break down is for cases where conditions are constantly changing and logic becomes just too complex. Take fraud detection, for example. A static rule like flag any transactions over $1,000 quickly becomes useless against fraudulent attackers whose behaviors evolve. That's where machine learning and statistics come in. Machine learning excels at learning patterns in structured data and making probabilistic predictions. Machine learning is ideal to use when patterns exist but aren't very obvious, rules are too complex to define manually, and when you need predictions. Some common areas of use are fraud detection, customer churn prediction, demand forecasting, and recommendation systems. Here's an example in practice. If I want a system that forecasts product demand. A human might rely on intuition and bias, and a rule or code solutions may be too simplistic to pick up on the nuances of demand trends. This is where machine learning shines, able to learn complex trends and patterns in data, resulting in more accurate predictions and improved model outputs, making it the ideal system for this particular task. Machine learning models scale very well and are generally predictable. However, they do require more monitoring and ongoing maintenance, as over time there can be model drift and low flexibility outside the initially defined problem scope. Machine learning models do also have varying degrees of explainability, but if you needed to write a report on what it thinks the societal causes of these demand trends are, you're out of luck. While the task of analyzing and predicting trends over massive structured data may not be ideal for your typical LLM, they are good at working with unstructured data and tasks that involve reasoning, synthesis, and language. Generative AI systems like LLMs and agents are best to use when inputs are unstructured, like text, documents, and other media. Tasks require interpretation or transformation. Flexibility matters more than precision, and some amount of error is tolerated. Some common examples are retrieval-augmented generation for question answering over document sets, large document summarization, code generation, and multi-step workflows with agents. Take a customer support system, for example. Instead of hard-coded responses to user questions, an AI agent can understand intent, pull relevant knowledge, and generate a unique and helpful reply. Trying to do so with rules alone would be nearly impossible. Generative AI systems are incredibly flexible, and time to success is very fast, with LLMs being such good generalists at tasks. However, the trade-off is non-determinism in answers leads to difficulty in testing, correctness not being guaranteed across runs, and they tend to be significantly more costly at scale than these other tech solutions. That is really the key to knowing whether or not to build agents and LLMs for your tasks. How much non-determinism and uncertainty are you willing to tolerate? For example, if I want an AI agent to analyze my spending for the year, I can't just feed in thousands of transactions and expect it to create a non-hallucinated answer or even just get the calculations correct. Instead, I might want a calculator tool that uses code and math for determinism and traditional machine learning to identify trends over time. And of course, I might want an LLM to still generate a nice, clean, natural language report at the end. These hybrid systems tend to be the most successful, using all of these types of solutions in conjunction, properly balancing the correct tool for the task. When someone says to make everything agents, this is not literal. All of the best agents and modern solutions use some combination of all of these types of systems. It's important to identify and think out where each of these are most appropriate to apply. Here's an actionable heuristic. Use humans when you need judgment, accountability, and ethics, or have high-risk workflows. Use rules or traditional code when you need clearly defined logic, as if X happens, do Y, and that logic won't change often. Use traditional machine learning when you want to find patterns and predictions in past data. Use generative AI when you need to interpret, generate, or reason over complex inputs, and flexibility matters more than precision. In general, what's most important is matching the technology to your use case and choosing the right kind of intelligence for your tasks. Most failures to get to production aren't going to come from bad models, but rather from choosing the wrong system in the first place. The future of technology isn't about replacing humans or putting AI everywhere. Great systems are built by making disciplined choices about how decisions get made across humans, rules, models, and machines. The most successful AI systems likely won't be the ones using the most AI. It will be the ones who consistently choose the right kind of intelligence for the problem. Because the most important AI skill is knowing when not to use it.